Hello everyone. In this video, we will learn how to integrate the functions which are product of odd powers of secant and tan. Tan to the power 1 times secant to the power 3 or any other powers, we will learn how to integrate these integrals. Well, the first thing that I should recall here is a simple differentiation fact that the derivative of secant x is secant x tan x. Well, as a result of that, the differential version of this, the differential of secant x, this is when we try to use the substitution, is helpful, is secant x tan x dx. Or the equivalent version of that will be, so these are basically saying kind of the same things, integral of tan x secant x dx is just secant x plus c. Well, that is the first possible case. The power of tan is 1, power of secant is 1. And what we just mentioned basically says that, well, you don't need to do anything there. That's an item, an entry in the table of integration. Tan x times secant x dx is secant x. How about other odd powers? Okay, let's go through some examples and I will tell you what are the key points to see and what are the key steps to take. Okay, so I'll start with this one. Note first thing is that the power of tan is 1, power of secant is 3. Both of them are odd. So if I start going with that integrand, I would like to use this fact that I mentioned up there. I noticed that I can separate a factor secant x times tan x dx. And then the remaining will be only just secant squared x. Note that to start with, both powers were odd, but we're taking one from each one, so the powers will become even. This will become important for us in the next example. But okay, now you see this is derivative of secant. It means that if I go with u substitution by setting u to be secant x, I already have du there. So that is secant x tan x. I'm changing the order all the time, doesn't matter here in this case. So this is the u, yes, and then, well, the rest, this is just u to the power 2. So everything is ready for us to carry out the substitution and turn our x integral into u integral. And when you're there, well, that is just a simple power rule which tells me what is the integral. But we are not done with substitution, because in the substitution there's this very last point, the very last step, that you have to plug in back your original function, in this case secant x, and put it as u in the final answer. So this is secant to the power 3x 1/3 plus 3. So the take-home note here is that when the powers are odd, when both powers are odd, we can separate a power, a factor, or the factor tan x, just one power from tan, one power from the secant, and use it to generate du when we set up u to be secant x. So that is the key point that you have to keep in mind here. And well, when you do those steps, it will work out unless only one thing could be new, and this will be shown in this example. So here the powers are odd, and I'll start 10 to the power 5x secant to the power 3x dx. That first step is always there, so I will take out 10x, 1 power from 10, 1 power from secant. Then the remaining ones will be 10 to the power 4x secant to the power 2x. Okay, so let me just push this back a little bit. Now it's time to start u substitution. U substitution here again, while we are setting the secant x to be u, then du is going to be well, what we have there, secant x tan x dx. So this part is du. This one here is u squared. How about tan to the power 4? So that is something new for us here, yes? So for that, we know what to do. We have an identity which says tan squared x is secant squared x minus 1. Okay, you say that's for tan squared. How about tan to the power 4? Well, we can deal with tan to the power 4 by doing this. Tan to the power 4 is tan squared, then squared. Yes. And then we replace that tan squared inside by secant squared x minus 1 squared secant squared x tan x secant x dx. Yes. So by doing so, we turn that remaining even power of tan and write it in terms of secant. Actually, secant the squared. We wrote it in terms of secant the squared. But what was important for us was that now everything is ready for transition from x integral to u integral. Yeah. So let me write it back here. So I have u squared minus 1 squared, so it will be u4 minus 2u squared plus 1 times u squared du. You multiply u to the power 6 minus 2u to the power 4 plus u squared. I multiplied that inside, and then apply the basic rules of power rules and linearity of integral and all those things. Let me open a little bit more space here. So that will be u to the power 7 over 7 minus 2u to the power 5 over 5 plus u to the power 3 over 3 plus c. And we are not finished unless we plug in back our original function. So that will give me 1/7 of secant to the power 7x minus 2/5 of secant to the power 5x plus 1/3 of secant to the power 3x plus c. And well, the note here from this example, take home note or lesson, is that the remaining even power of 10, which is even power, yes, originally we had odd, we took off one of the powers, put it aside, that factor, and then the remaining is even. Use can be written in terms of in terms of secant x using the identity tan squared x is equal to secant squared x and minus 1. So that is the step we have. And if you know these two steps, these two notes, it's done. You can do any, integrate any function which is product of odd powers of tan and secant. Let's do last example for this video. We are trying to find the average value of this function on that interval. Well, remember that the average value of a function on an interval AB is 1 over the length of that interval, which is pi over 4 minus 0 integral of that function on that interval. So I will take the integral and integrate that and then bring it back and put the value there. Tan 3x secant x. Note that both powers of tan and secant are odd, so I will separate the factor tan x secant x dx. The remaining is tan square x. You're going 0 to pi over 4. And we are almost done. We can do the substitution u equal to secant x, but I have to use the identity tan squared is secant squared x minus 1 times well, the rest. Yes. Now everything is ready for u substitution. So let me just write u sub, and I have u equal to secant x. I have been written that thing all the time in this video. So tan x dx. But well, that will take care of this part. That will take care of this part. But this is definite integral. Okay, so when you apply u substitution to definite integral, you have to apply the change of limits as well. Okay. So if x is 0, u is going to be secant 0. Remember, secant is 1 over cosine. Cosine of 0 is 1, so 1 over 1 is 1. Well, how about pi over 4? Secant of pi over 4 is 1 over cosine of pi over 4, which is 1 over root 2 over 2, but that will just give me just root 2. So now having all this ready here, I can change my x integral to u integral, u squared minus 1 du, apply the fundamental theorem of calculus, use the power rule for the integrals, yes, and then fundamental theorem of calculus here says that this will be root 2 to the power 3. That's root 8, and that's the same thing as 2 root 2 over 3 minus root 2 minus, plug in 1 to the power 3 is 1, and that is what we have there. Yes. So I have 2 over 3 root 2 minus 1 root 2. Yes. So that will give me negative root 2 over 3. The second one is 2 over 3, negative 2 over 3, there's minus sign, that will be plus 2 over 3. And I can simplify a little bit more. So I can write 1, 3 in the denominator, and that will be 2 minus root 2. So by these examples, now we know how to integrate those functions, even powers of tan and secant. Now, let me just finish video with the summary of what we learned. So both tan and secant have odd powers, they are multiplied. What we do, oh, there's a typo here, this will be 2n plus 1 there, yes. So what we are doing first step is that separate the factor or a factor tan x secant x. The power, oh no, actually it was good, I don't need that because I already separated one. Then use the even power of 10 and write it as this 10 squared to the power some number. Use this identity, change and write this 10 squared x in terms of secant. And that way your substitution u equal to secant x turn your integral to an integral of this form. And that's just an integral of polynomial. You expand the integrand. Well, if m is low number, you can easily do that. And then you will just get a polynomial, apply the basic rules of integration, and you have